everyone, this is Santhosh Kumar. Welcome to MAXLOGICALS. Today I introduce the one topic, that is the differential equation. First of all, we going that before we want to know the what is the definition of the differential equation. The definition of the differential equation is an equation involves one dependent variable and one or more independent variables is called the differential equation. Example, dy by dx plus x equal to 1. This is my differential equation. Now what is the order of this equation? Let us discuss the what is the order of this equation and the degree of this equation. The order means highest derivative of the differential equation, and degree means highest derivative of power of the differential equation is called the degree of the differential equation. For I have the one differential equation, that is my differential equation is, this is called by star, that star is dy by dx plus x equal to 1. This is the differential equation. What is the order of this differential equation? Here order means highest derivative of the differential equation. How many derivatives this equation involves? One derivative. So order of the star is 1, and degree highest derivative you have 1, highest derivative power is also 1. This is the order and derivative. Again we take the another differential equation, that is d square y by dx square plus dy by dx plus 2x equal to 1. This is the another differential equation. Now we discuss the what is the order of this differential equation and degree of the differential equation. Here how many derivatives involved in this equation? Here two derivatives here involved. So order is 2 and degree is highest derivative power is 1. So the differential equation degree is 1. This differential equation, we have some methods to finding the solution of the differential equation. For example, we have the one differential equation. That differential equation we want to find the what is the solution of the differential equation. These four methods will be helpful for finding the solution of the differential equation. That is, the first method is variable and separable, and the second method is linear differential equation, and the equation which in the form of linear differential equation, then we finding the solution by using the process of the linear differential equation. And third method is non-homogeneous equation and homogeneous equation, and fourth method is Bernoulli's differential equation. These four methods are very helpful to finding the solution of the differential equation. In this video we are discussing the variable separable and linear differential equation, and the next two or three videos we will discuss the non-homogeneous equation and homogeneous equation and Bernoulli's differential equation. Let's see the variable separable method to finding the solution of the differential equation. If the equation dy by dx equal to f of x plus f of y, this is my differential equation. Here we do the variables are separated. That is, where f of y dy equal to f of x dx. Now integrating on both sides, where f of y dy equal to integral f of x dx. That is integral f of y minus integral f of x dx, where f of y dy, that equal to 0. This is the method for to solving the differential equation. Let's take the one example, that is where dy by dx equal to x by y. This is my differential equation, and to finding the solution of this differential equation, that is y dy equal to x dx, that is y dy minus x dx equal to 0, integrating on both sides. Integral y dy minus integral x dx equal to integral 0. And what is the integration of the y? Y square by 2 minus x square by 2 equal to c. This is the solution of this differential equation. This is the solution of the differential equation. Here my differential equation is dy by dx equal to x by y. We are solving these differential equation by using the variable separable method. That is, we get the solution y square by 2 minus x square by 2 equal to c1. And the next method is linear differential equation. If the equation is in the form of dy by dx plus p of x into y equal to q of x. If the equation is in the form of dy by dx plus p of xy equal to q of x, is called the linear differential equation. If the equation involves one dependent variable and one independent variable, and the order and degree of the LDE is 1. This is the linear differential equation. Now, how we finding the solution of this differential equation? First of all, we finding the integrating factor of this differential equation. The formula of integrating factor is e power integral p of x dx. Now, these integrating factor, the solution of the differential equation is this integrating factor I called by a into y equal to integral q of x into a. This is the solution of the given differential equation. Now let's take the one example. Is where dy by dx plus 1 by x y equal to sin x. This is my linear differential equation, because I have in my equation have the one is the degree and one is the order. So this equation is called linear differential equation. So we can solve this equation by using the linear differential equation method. First of all, this equation we comparing with general form of the differential equation, linear differential equation, that is dy by dx p of x y equal to q of x. What is p of x? P of x equal to 1 by x and q of x equal to sin x. This is my p of x and q of x. Now to find the integrating factor, where if equal to e power integral 1 by x dx, that is e power x log x. Here e log are cancel, or if is integrating factor is x. Now these all values are substituted in general solution of the linear differential equation. The general solution of the linear differential equation is integrating factor into y of x equal to integrating factor into q of x. This is the general solution of the differential equation. We have the q of x value and we have the integrating factor value. So these two values are substituted in general form of the general solution of the linear differential equation. What is the integrating factor? Our integrating factor is x, y of x equal to integral, what our integrating factor is x and our q of x is sin x dx. Now finding the integration of this function. Here we have the two functions, one is x and one is sin x. We have the integration is also. Before we going that, we remember the Euler formula. We remember the Euler formula. You know already what is Euler formula. Euler here, I means inverse function, and L means logarithmic function, and A means algebraic function, and T means trigonometric function, and E means exponential function. First we consider that x is algebraic function and sin x is trigonometric function. So first we consider the algebraic function. X integral sin x minus integral differentiation of x integral sin x dx. X, what is the difference integration of the sin x? That is minus cos x minus integral differentiation of x 1 minus sin x minus cos x. Integration of sin x is minus cos x. That is minus x cos x plus integral cos x dx. Minus x cos x plus what is the different integration of this cos x? That is sin x. This is the integration of the x sin x. Now x y of x equal to what is the integration of this function? Minus x cos x sin x plus c. Here y of x equal to x cos x plus sin x plus c by x. This is the final solution of the given differential equation. I hope these two methods are clear for all of you. If you have any doubt, please comment in comment box. We will discuss again and again in another videos. Please do like, share and subscribe to our channel. Thank you for watching this video. Thank you to all.